Welcome to ML with AP. In the last two videos, we have seen the simple linear regression and we have done it with the Excels. We have also understood various parameters which the Excel was throwing, right? Now in this video, what I'm trying to do is that through scikit-learn, which is a package in Python, and a Statsmodel, will try to arrive at the same thing what we did through our Excel exercise, okay? Now let's go ahead. So this was the output of our Excel variable when we did this analysis through Excel in the last video. If you have not watched the last two videos, it's very important to make sense out of this video that you should completely watch that, okay? But in nutshell, these were the coefficients which my Excel regression output. The intercept was 51 point something and my odometer reading was negative 0.28, which makes sense. The prices go low when the odometer reading goes high, so it's a negative correlation over there, okay? And this was my car data, right? So let's go ahead and go to our Jupyter notebook, okay? So friends, what I'm doing over here is importing some library. This is the matplotlib magic function, so that the pictures comes. I'm importing matplotlib as PLT. NumPy and pandas are imported. Since I have a CSV file, I have to read them. And from SKlearn model, I'm importing linear regression. The first thing I'm doing is I'm reading the pd.read_csv. cars.csv is the data which I have already kept in the local folder, okay? And this is just cars.csv, right? So this is a CSV file, okay? And when I did, let's run it, okay? When I did, my data frame looks like this: the odometer reading, price, and these are the 15 observations. The indexing starts from 0, that's why you are seeing 14 over here, okay? Now I try to put the data.columns. What are the columns? I have odometer and price. What I did is from pandas data frame, I have tried to get it into NumPy arrays, right? Because I have to pass it to the scikit-learn. I will convert them, and the conversion is through that values, right? So I converted. When I printed my X and my Y, it printed nicely. And let me just show you the type of X over here. And the type is ND array, right? So I convert it into a NumPy array, okay? Now I try to plot this using matplotlib. Let's see, this is just a scatter plot to show you the data, and the data is like this, okay? Plotted. Nothing fancy over here till now. Now here is the thing what we are trying to do. Through SKlearn linear model, we'll try to import linear regression, okay? We did this reshape over here for both the X and Y, and after that it's very simple in scikit-learn. What we are going to do is we created a model object and we called linear regression, which we imported just now. We already have the X and the Y ND arrays, NumPy arrays, which we are passing. We are doing the model.fit. Here we are not doing train test split or anything like that. We have only 15 observations. We are trying to see that how linear regression works in the scikit-learn, and we are passing all the variables over here, okay? We did the model.fit. Now I am importing this into another variable, which is xfit, and what I am trying to do is I'm trying to predict again back that my Y was my observed, X was observed, and I have got a model after model.fit, a standard procedure in scikit-learn. And then what I'm doing is I'm doing a model.predict. So I'm going in my y.fit will be my predicted values. In x.fit is nothing but x itself, okay? So I ran this, and let me run xfit and yfit also over here, okay? So these are my odometer readings, right? If you see, and these are my prediction of the prices for my observed value, which is this, right? So friends, if you see over here, the prices were in whole numbers, right? In thousands. But when I used the model, it gave me this, right? And what I'm trying to do is I'm trying to plot. Obviously, when I'm trying to plot, everything will lie on this particular line, right? So this is the line which I'm trying to get. After that, we have to get the model slope and model intercept, like how we got over here in case of model slope, intercept, and slope, right? We got through Excel these two variables. We are getting it through over here also. The slope is minus negative 0.2843, which is same as negative 0.2843, and we have got 51.12 as the intercept, right? As 51.12 as the intercept. Okay. Now the model data score, if you see over here, you just have to do the model data score and no price for guessing that what it is going to 0.080%, right? So it is giving you the model of score is nothing but your R square, right? This is the good of the fit model. This is the good of the fit test. So how good is my model? How good is my linear regression model? 80% of the data distribution can be explained by this particular straight line. That's all it is saying. Okay. Now, unluckily in scikit-learn, like there are no method which can give you a detail like this what Excel has given you. So what I have done is I have imported another library which is very good, Statsmodel. Okay, I have imported statsmodel.api. Again, very simple, ordinary least square. I am doing a fit on it, and I am printing a model summary. If you print a model summary, it gives a much more detail and somewhat similar to what R or Excel would have given. Okay, so if you see the R square is this, adjusted square is also given over here. My ordinary least square model is there when I have run and everything, right? The coefficient, if you see, again, the coefficient is is the same what was generated through either scikit-learn or through your Excel sheet. A standard error, again, t distribution, the p-value, okay, and the confidence interval, everything is given over here through the Statsmodel API. So in case you want to leverage or you have to see the linear regression other parameters also, you can do that. Okay, but for more generic nature, just for the prediction, people usually do not prefer this. They go with the scikit-learn. It's easier interface and all, and they only see the model accuracy. Okay, so friends, this is, I think, it for the single linear regression. This was a 3-part series of videos. The first part, this is the third and the concluding series. If you want me to make more such content, please comment. I'll try to link the Jupyter notebook and the Excel sheet in my GitHub repo. You can see it from there. With that being said, thank you. Bye.